Hi again everyone, this is the second part to the work solutions for the Trial-HSC exam for General Maths. What I'm going to be doing for this video, rather than making it one big video going through all of section 2 with all the free response bit, because that'll take too long, that video will be likely to be an hour if not longer, probably like an hour and a half. So rather than doing that, what I'm going to do is I'm going to split it into each different question. So I'll have one video on question 26, another video on 27, another video on 28, another video on 29, another on 30. That way you'll be able to go through each of them at your own speed, do it at different times, and it should be easier for me to create them as well. So we'll get right into this. This will be for question 26, and then I'll probably get 27 probably done also tonight, and then 28, 29, 30 sometime later this week. So let's just get straight into this first question. So we get given this pie graph, and the chart above shows the household water used in a suburban Sydney home. So there's a typo there, but whatever. If the average annual water used last year was 290 kilolitres per household, how much was water consumed in the laundry? So basically, we have this pie graph, and it's got the different categories in which everything was used. So if we're going to just take a bit of information from here, we know that everything here needs to add up to 100% because, that's what it is. 100% is the actual thing. So if I were to I just need to find, first of all, what percentage is laundry, first of all. So once I have that, I'll do 100, because we're saying we'll do 100, just minus the 5%, minus the 10%, minus the 30%, and minus the 35%. Which equals 20%. Alright, so straight away we found that this laundry accounts for 20% of the water usage. You take that from everything, basically what's the remainder. But that's not what the question's asking. The question's not asking what percentage of water, it's asking how much water. So now that we've got that, we're told that we used 290 kilolitres, so therefore we just need to find 20% of 290 kilolitres, which equals 58 kilolitres. So that's the answer for the first one. It's just a matter of finding what percentage is missing, and then finding that percentage of the whole thing. Alternatively, what you could have also done is found 80% of the 290, because that's what you already have there, and then taken that away from 290, and that would also work. Going to this next page. So here we have this big ugly formula for the number of bacteria in a culture after tea time. So what we want to do here is we just make t equal 4, put it into the formula that you're given, and see what n equals. But the key thing here is, and this is something that I noticed happening quite a lot, it says to 3 significant figures. It doesn't say 3 decimal places, and it doesn't say anything about scientific notation here, which is something that I also noticed. Quite a few people are just doing scientific notation. So what we're going to do here is we're making t equal 4, so we're just going to replace that t with 4, and you literally just put that into your calculator. When you put that into your calculator, you'll get n equals 15,422.90. Once you have that, we don't need it to 3 decimal places or anything like that. You can't leave it like that. It says to 3 significant figures. So what we're going to do here is we start at the first non-zero, go across 3 because we're doing 3 significant figures, and then stop it there. But you can't just say 154 either, because 15,422 isn't kind of like 154. It's kind of like 15,400. Alright, so there's my 3 decimal place, my 3 significant figures, and everything else turns into a 0. Now you could change these into zeros as well, but I mean at that point you might as well just write that. So those zeros afterwards aren't necessary. So that's the answer for that. Making sure I'm reading the question carefully. 3 significant figures. Going to this next question, we have this car yard, which record the number of sales. We're told that the owner wants a monthly mean to be 510 cars. So how many cars will need to be sold in December? So what we need to find, first of all, is we need to find how much all this adds up, okay? And if you do add all those up, that will equal 5,674. And when I was marking it, I noticed that some people kind of on the right track here, except they might have accidentally pressed one of the numbers twice. I don't really like this question because you're having to add like 11 different numbers, all with 3 digits. So there's like 33 different button presses, and if you make one silly mistake, you get the question wrong. So you just need to be careful when you do it. Maybe even do it twice just to make sure. But anyway, so once you get that, and let's just call this value that we're trying to find, let's just call that x. So that means if we were to add 5,674, because that's the first 11 months, plus that last month, what we're trying to find, the average of all of that, so divide by 12, we want it to equal 510. So let's just take a step back there for a second. We want to find the monthly mean for the whole year, okay? So that means we have to divide by 12 for the whole year. And we need to realize, well, we're adding everything up for the whole year. For the first 11 months is 5,674, and we're just adding that x on top of it as well. So now you just have an equation that we want to solve. So first of all, we're going to multiply that 12 over, which will give you 5,674 plus x equals 6,120. So what I did is just multiply the 12 over. Remember, we want to get rid of the thing that's furthest away from the x first, which is the 12. And once we've done that, we'll just subtract 5,674. So x equals 446. So what I did there is minus 5,674 minus 5,674, giving me the answer 446, which is the answer. And going to this last bit, so here we want to calculate the percentage error in a measurement of 2.75 meters. Again, this is quite a tricky question. I don't like the fact that it's in question 26, but anyway, what we need to do is we need to find what the limit of reading is, therefore find what the error is. So what we notice here is this measurement is to 2 decimal places, okay? That means when measuring it, the limit of reading, is to 2 decimal places, meaning like the closest it can be is 0.1 meters, right? Or I guess, what's that, 10 centimeters. So if that's the limit of reading, because we're measuring it to 2 decimal places, that means the error is half of that. So the error equals 0.01 divided by 2, which equals 0.005. So that's the maximum error we can make in this measurement. So what we want to do is we want to find the percentage error. We don't want to just find the error, otherwise that would be the answer. We want to find the percentage error. So we're trying to see how far off this measurement could have been. So we're going to get that maximum error to 0.005. We divide it by the measurement that we made, so 2.75. We'll times it by 100, and that will give me 0.18%. And again, reading the question carefully, it says to 2 decimal places. Quite a few people lost marks throughout this test just due to not rounding, like reading the question and rounding appropriately. Okay, read the question carefully. You don't want to make silly mistakes like that. Going into the next question, we see that Anthony borrows this amount in flat interest over 5 years. The total that he pays is that amount. So we want to calculate the annual rate of interest charged on the loan. Now, quite a lot of people did this okay, but a common mistake that I saw is people started immediately using those two numbers that we have there. But problem is we don't actually have the interest there. We need to first of all calculate the interest. People notice that we've got flat rate, so therefore we have I equals PRN. And we'll just go ahead and reverse that. But in this case, we don't know what the interest is yet. We need to calculate that. So let's first of all find the interest, which is 21,450, because that's the total amount he repaid. And we have to subtract that from the principal, which equals 4,950. So that's the interest that we're going to use for this equation. Not the 21,450, that's the interest. So therefore, we're going to do 4,950 equals 16,500. So P times R times N. Okay, well, in this case, n is 5, because we're told it's 5 years. So once we've got 5 years, we'll just divide the two things over. So we've got 4,950 divided by 16,500 divided by 5 equals r. So therefore r equals 0.06. So that's it as a decimal, and that's fine. You just leave it like that. That's your answer. But what I noticed some people doing is they'll therefore saying therefore the rate is 0.06%, which isn't true, right? It's not 0.06%. That's an amazingly small percentage if you really think about it. What the rate is, if your decimal is 0.06, therefore the rate would be 6%, right? Because percentage is as per 100, so you do 6 divided by 100, which is 0.06. Alright, so you just don't want to make a mistake there. You don't need to do that last conversion to a percentage because it doesn't say it needs it as a percentage. So if you just left it as 0.06, that would be fine, or 6 over 100. Going to this next question, we've got this person Sven who lives in shared accommodation. Is required to pay his share of the electricity. Each month he pays $15 plus 20.8 cents per kilowatt hour for the electricity he uses. Sven wants to keep his cost to $80 or less each month. What is the maximum number of kilowatt hours of electricity he can use? So we're told that straight away that this guy is paying $15 plus everything that he uses. So he's going to pay that $15 straight away, which we need to factor that into that $80. Okay? So we're going to just do 80 minus 15, which equals $65. So that means his electricity use, this bit here, is what we need to work with the $65. So now we need to figure out how many kilowatt hours, how many lots of those 20.8 cents will make $65. Now, quite a lot of people from this point now divided this by 20.8. Problem is, that will be $20.80 per kilowatt hours, but it's 20.8 cents. Alright? So what we need to do is realize that that is 20.8 cents is $0.208. So once we have that, we're going to have to get our 65 divided by 0.208. Just reading the question carefully, it's saying cents, not dollars, which equals 312.5. So therefore, the maximum amount of kilowatt hours this guy can use is 312.5 kilowatt hours max. Right? That's the most amount of kilowatt hours he can use before he starts paying $80. So the idea is if he uses anything less than 312.5, his electricity bill will be less than $80. Anything more, and it will be more than $80. If we scroll down to the next question, question G, we're saying that Clive surveyed the Year 11, Year 12 students at his school to determine whether or not they had a part-time job, and then we get this table below. So what percentage of surveyed students had a part-time job? So this was done fairly well. What we first of all need to realize is how many people were actually surveyed. So what we'll do, we'll just do 46 plus 50 plus, 46 plus 50 plus 29 plus 25. So here we have 150 students in total, okay? So we're going to be using that. But then what we also need to do is we need to find how many of those 150 students have a part-time job, because that's what we're trying to find the probability of, or the percentage rather. So here we need to look at the works part-time column, and we'll see that 46 plus 50 equals 96. That means there's 96 of these 150 people, 96 of them do have a part-time job. So therefore, it's just a simple matter of 96 divided by 150 times it by 100, and that gives you 64%. Alright? It's not asking you for like a fraction percentage probability. If you just wrote 96 over 150, that wouldn't be correct, because the question is clearly saying what percentage. It's not just saying what probability. So yeah, making sure again you're reading the question carefully. And then going on to this last page for question 26. Here we have kind of like a right angle triangle question. There's two ways of tackling this. What I might do is I'm going to do it a way using trigonometry, but there is also a way using similar triangles that slightly more complicated. But anyway, we have a man who is 1.7 meters tall, casts a shadow 2.6 meters long, when standing 9.4 meters from the base of the tree at level ground. So basically you have that diagram there, so I don't really need to look too much more into it. I just want to calculate the height of this tree. So what we want to do here is we're trying to find this length, okay? And we see that we have like a big right angle triangle. Okay, so if I were to just kind of like highlight that big right angle triangle, but inside of it, we also have this smaller right angle triangle. And what we're going to do is we're going to use both of those pieces. Because with this little green triangle that we have down here, we do have two sides. We know that's 90 degrees. And what we can do is if we can find that angle in there, let's just call it theta. Once we have found that theta, we can now use that angle for that big red triangle. And we can just use some SOHCAHTOA. So we're kind of going to use SOHCAHTOA twice here. First with that little green triangle to find the angle. And then once that's done, for the big red triangle to find the side length. So I'm going to do this question in two parts. First with in green, to say that I'm talking about the small green triangle, and then in red. So here, looking at this, if we're looking at this theta, this is the opposite, that's the adjacent. So the ratio that goes with opposite and adjacent is tan. So therefore, we have tan theta equals 1.7 over 2.6. Remember, opposite over adjacent. And so remember, whenever we're trying to find that theta, we're going to say that theta equals inverse tan. So that's when you press your shift. So shift tan of 1.7 over 2.6. And when you put that in your calculator, you get about 33.178 ... And I'm just going to save that into my calculator. So I'm just going to call that A. If you store that into A. So now we've found that that angle there is approximately 33 degrees, right? We won't say it's exactly that. Remember, you don't want to round right into the end of the question. So now that we have that, we now have this big triangle. And with this big triangle, we now know what this theta is, okay? And we know that this long side on the bottom is the adjacent, and we know that this is the opposite. So again, we're going to use tan, except this time we're not going to use 9.4 or 2.6. The length of this whole side at the bottom is going to be this 9.4 up to this point, plus this 2.6. So the adjacent in this case is going to be 12 meters, because we're going to add them up. You do 9.4 plus 2.6 equals 12. So you don't want to use 9.4, 2.6, you want to use 12. With this, we can now say that tan of that 33.178 ... like we still got that there from the previous thing. Just write A in your calculator. That equals H, the thing we're trying to find, over 12. And once we have that, we have H, the thing we're trying to find, on the top. So that means we can multiply 12 over. So H equals 12 times 10 of that 33.178 blah blah blah. When you put that into your calculator, you get approximately 7.8 meters to one decimal place. Now, in this time, the question doesn't specify to how many decimal places or whatever. So I just do one decimal place. You could do two decimal places, so it doesn't really matter. So quite a bit of work for 2 marks. Again, kind of tricky for question 26, but not overly too bad. It's just 2 applications of SOHCAHTOA. And then lastly, we have this person Ryan who's transferred to his laptop 2 episodes that totaled 900 megabytes, which took that amount of time. And then Austin downloaded a 2 gigabyte movie, which took 79 minutes and 32 seconds. So what we can do here, well, what Ryan's saying is that his laptop is faster. So what we want to do is put that claim to the test. So let's first of all look at Ryan's speed, okay? what we want to do, by the way, is we kind of want to compare both of the download speeds. So how about we find the speed of megabytes per minute, okay? So if we can find both of their download speeds as megabytes per minute, we can then therefore just compare the two. Actually, in my solutions, I've done in seconds, so we might as well just do it in megabytes per second, and then again we can still compare them. So looking at Ryan, it took him 37 minutes and 27 seconds. So what we can do is we want to find how many seconds that is in total. We'll do 37 times 60, and then we'll add that 27. So it gives me 2,247 seconds. So therefore, he's downloaded 900 megabytes in 2,247 seconds. But we want to make that as a rate per 1 second, because the whole point is we want to find the megabytes per 1 second, because it's going to be easier to compare. So what we'll do is we'll divide this by 2,247, but that means we also need to divide the 900 by 2,247, which will give me 0.4005 megabytes per second. Alright, so we're downloading just about less than half of a megabyte per second is Ryan's speed. Now that we've got Ryan's speed, let's go ahead and find Austin's speed now. And Austin's speed, that'll be 79 minutes and 32 seconds. Now, you might just look at that, well, of course, that's right. But I mean, his file size is like more than twice as big as well. So we need to kind of think about that. So once we have that, that's 4,772 seconds. So therefore, again, and again, we're trying to get megabytes per second, but this guy is downloaded a 2 gigabyte movie. So remember, 1 gigabyte is 1,024. So this is 2 times 1,024, which equals 2,048 megabytes. So once we have that, we know that we download 2,048 megabytes per 4,772 seconds, which equals 0.429 megabytes per second. So now what we've done here is we've found the download speed for Ryan, and we've found the download speed for Austin. Now just looking at those two speeds, going back to what the claim was, Ryan said that his laptop was faster, his download speed was faster. But in fact, what we're seeing that Austin's speed was faster, because he's downloading 4.29 megabytes per second, whereas Ryan's downloading less than that. So therefore, like a conclusion statement can be, therefore, Ryan is wrong because Austin has a faster speed. Or something like that. Alright? If you have enough calculations there, it's fine enough as it is. Anyway, so that's question 26 done, which will end this video. I'll go ahead and do question 27 now and upload it in a separate video, and we'll go from there. So hopefully this has been useful.